You need to be quiet. That's what it means. Otherwise, you'll get picked up, and you'll make it harder to go back in time and review what we're working on here. So, two questions. The first one, what is the probability of getting a sample proportion between 0.35 and 0.45 inclusive, right? So including 0.35 and 0.45 from a sample of 20.
Is it recording your voice or the screen?
Both. All right. So, how? Somebody have a suggestion, solution for this one? Yeah, Justine.
So the first thing you want to do is do 0.45 times 20, and you want to do 0.35 times 20. We already know what 0.4 times 20 is.
Right.
So that's equal to, from top down, 9, 7, and 8.
Great.
So those are basically the samples you're going to want to solve for.
Right. We want to know the probability of getting 7, 8, or 9 yeses.
Yes.
Right.
So to do that, you do 20C9
Okay.
times 0.4 to the 9
Yep.
times 0.6 to the 11
Right.
plus
Plus.
20C8 times 0.4 to the 8 times 0.6 to the 12
12.
plus 20C7
This is great. Yep.
times 0.4 to the 7 times 0.6 to the 13.
Ooh. Nice. Okay. Nice. So that is how you would calculate it. Did you get a number for that, Justine?
I was too big.
Okay. Who got a number for this? Who got a value for this? Who actually calculated it out all the way? Leon? Equals 0.54 or 54%. 51.
Yeah, I got 54 too.
54 versus 51, so low 50s. Anyway, this is how to do it. If there's a little disagreement, that's okay. So, looking at this next problem, little more labor intensive, right? Because if I want to know the probability of getting, right, I want the probability of between 0.35 to 0.45 yes, right? And in a population of 100, that is the same thing as saying how many yeses, right? How many yeses would I be looking for? The probability of getting how many yeses? What range of yeses?
35.
Right? 35 to 45 yeses, right? 35 to 45 yeses. I want to know the probability, right? The probability of getting 35 to 45 yeses. Okay? So let's just say I wanted to do one of these, right? Let's say I want to know the probability, because I think we follow the same rule or strategy that Justine had before, right? You would add the probability of 35 plus the probability of 36 all the way down until the probability of 45, which is gross, right? It would take a long time, right? Because the probability of 35, what would the probability of 35 be?
0.4.
I like it, yeah, 0.4 to the 35th times 0.6 to the 65th.
4.9 times 100C 35.
Alana, nice, times 100C 35. And Mackenzie, good, right? So this is one of the 10 that you have to crunch, right? You can save some time by using Excel, okay? And the instructions are on the worksheet, but I'm also going to do them here. You can label a column and say sample yes, okay? Yes number, right? Is that what I suggest? Wait, what did I say here? Number of yeses, okay. Number of yeses, okay, sample yes number, I'll call it that. And then, and then in the next column, we want to say the probability. Okay, and again, you don't have to be following along right now. This is going to be saved as a little video. So the sample yes, what's the smallest yes number that I'm looking for here? 35, okay? So my first number, I would put 35, okay? The next number would be 36, right? A way to save some time. You can hit the equals sign, click the previous cell, and then hit +1 and enter. Okay? So that means that this cell is A2 plus 1. Okay? And then what we can do is drag the lower right-hand corner down until it says 45. Okay? So now there are my sample yeses. All right? So now I've got the formula for the probability of 35 right here. Okay? So I can use Excel to do this for me. So I'm going to hit equals the combination, and it wants the total number in the sample, which would be 100, and then the number of yeses that I want. And how many yeses do I want? 35, but I really want this number of yeses, right? Because as I go down here, like if I keep doing this formula, I'm going to want this many yeses, okay? And then close parentheses, and I want to multiply that by, well, 0.4 to the 35th power, right? Times 0.6 to the 65th, right?
Yeah, but
But-
that minus
100 word minus this. And then I think that's enough, right? Then hit enter.
You gotta multiply it by 100.
To get the, yeah, so probability, and then it could say percent, right? Which would just be this amount times 100. Okay? So, again, to do it for the rest of these, you just click and drag all the way down. And then you can do the same for percents. And then what we really wanted to know, right, was the total, right? Was 35 through 45, right? So how can I add up a list like that? Justine.
It's equals sum.
Parentheses.
You would just
So there is a 73.9% chance that you fall between 35 and 45, which is greater than the likelihood for a sample of 20. All right? Which means that, wait, what do you know? Right, 54 versus 78.9. The more samples, the higher the probability over a certain range. We'll talk more about this later. There will be instructions for what to do in class on Friday, as well as some practice problems up on the board. Everybody have a good day. Also, by the end of the day, by early this evening, you will have